Hello everyone, we're back again. Sorry for the delay. We had some weird issue there. I think the problem was that I accidentally tried to power the servo off of the computer, which is of course a no-no because the computer cannot provide enough power for the thingy. So, I guess they all have to be plugged into the same ground, right, Alan?
Yeah, you need a common ground.
So I'm gonna send. I think I'm gonna need one here to plug into that as well. Blarg. Here we go. One of these. Grab one of these blue ones. And this is going to go from here, just so that all of them share common ground, right, Alan?
Yeah.
So now the Arduinos connect up to the ground. Battery pack is connected up to the ground. And this guy is connected up to the ground. Right? The power of this, the motor, is connected up to the batteries.
Yes.
And the signal of this will be connected up to the Arduino.
Correct.
So I need another pin. One moment. Let's grab. I guess we'll use yellow for signal. Yellow seems like a good signal wire. And we're gonna go from here
That should be the orange. The signal.
into the signal, which we haven't set a signal wire yet.
Yep. So we have to look at.
We have to go into our
documentation
Arduino
here
here.
again.
I'll have to open Arduino again. There goes. The blink sketch is there. We'll close that for a moment. Close that. And we're going to grab a sketch, right?
Yeah. We need a sketch to just maybe move a servo in a short cycle. Servo test of some kind.
Let's just try sweep.
Yep.
So this one here.
Yep, that should work.
Okay, so let's make a new sketch. There we go. We should probably include that one in here. Is now servo motor. Oops. And we'll save that as servo sweep.
So not sure.
Oh yeah, here we go. There we go. It's like that.
Yeah.
Now it's on the
There we
screen.
go. Yeah. So now we just have to compile this.
This keeps on freezing, eh?
That's because we switch away from it. So unfortunately, you've said full screen. We want to maybe make it partial. That way, it's.
I wish that. How do I don't even know how to do that.
Let me see the way we can actually get the stream itself directly from it.
Okay, apparently, as long as I have it on screen, it's still fine. Okay, so now we've got this here. And what are we going to do with this? This is just it, right?
Yeah, we just have to connect it up and upload it. So, I have to rehook this up back up.
Hopefully, okay, guys, pray for us. Hopefully, we don't die again.
Yep, that seems recognized. It's blinking. Let's move it around so people can see what's going on. And I guess you can upload the sketch now.
Let's do it. Okay, so upload using programmer.
Mm-hmm.
It's going in. It's uploading.
Mm-hmm.
Take a drink. Done uploading.
Okay, and let's see here.
Oh, because we haven't set the signal wire.
Yeah. Mm-hmm.
The signal wire is pin 9.
Mm-hmm. So which pin?
Crap, which pin is pin 9 now?
Okay, which pin have you hooked it up to?
I have to find out our
Yeah.
Arduino map.
Yep, we're missing the signal wire here.
Arduino pins, maybe. I'll once I find a good picture, guys. I'll put the pin picture that I'm using on the stream so you guys can see what I'm doing. It's like this, right?
So we want the let's see which one is that? Pin 9.
Pin 9 is going to be this one here.
PWM. Okay, so
I think I tried to make it so that it was similar
mm-hmm.
to how... Oh, no, I didn't. This is a simplified one. So this one is literally just the pins where they are.
Mm-hmm.
I have to
look at the literal pins.
look at the literal pins. Do I have a circuit diagram, maybe?
Look up the at mega, I guess. Pin out.
Oh, here we go. This is more useful.
Mm-hmm.
So I'll just save this picture. Oh. In my pictures folder.
Mm-hmm.
Not in that folder.
I want to put it. You have a project folder for this, right?
Yes.
You should go to your project folder, your documents.
Quadruped, right?
Yep.
There we go.
Mm-hmm.
Save that one there.
Mm-hmm. Are you
And
seeing these Arduino files in there too?
No, the right now they're just are the Arduino library.
Yeah, we probably want to put them in the same place. That way it's easier to find. Later.
Yeah. Well, right now they're just generic
Okay.
ones. They're not super.
Mm-hmm.
This is what's it called? At Mega 329 or whatever.
Mm-hmm.
So we're gonna go over here, documents, or yeah, we're gonna go to quadruped. This is a very technical image, guys. But let me just make it really big for a moment. So we can take a look at this picture here. We can see that we have all the pins laid out, and we're looking for digital pin 9. So digital pin 9, it looks like it's the pin number 15 that's all the way in the bottom right. That's digital pin 9. So, okay, so now we can close this for a moment. We can find it on the actual thing. So that's the pin 9's actually down here. It's this guy here. So if I plug it in, maybe we'll get some action.
Control. And oh, yes, looks like it's sweeping.
Look at that. Alright guys, so now we've got some action. You guys see here? Our servo is sweeping. There it is, guys. So it's moving back and forth, back and forth. I'll move it all the way up so y'all can see it. So now that we've got it sweeping,
Now the next stage is to try to get Arduino to communicate with our extender.
yes.
Mm-hmm.
There you go. So that's what it's supposed to do. And
I guess we can test each of the motors in that now.
ooh, good call, good call.
So now that we understand that this works, we can just
Yeah,
try
let's
plugging
test them
in.
out. Let's just test them out.
Mm-hmm.
So let's test this one next.
Mm-hmm.
Okay, can you hold on to that one, Alan?
Sure. Over here.
Okay. Here we go.
Signal is orange. Yes, it's working.
There we go.
Okay,
Look at that.
Let's actually now
Perfect.
just take test ones in the frame.
Okay.
Move this out of the way.
Let's test these ones in the frame.
Mm-hmm.
Let's test.
One picker motors, I guess.
Let's take this one. Let's test these ones in the back
Sure.
first. Okay.
I'll hold it over here. So
Right.
this one we're testing. Yes, that works. Now we'll try this next one. So this is actually a good way to test things.
Yeah. This is great. Okay, so we'll do the next one now.
Next one. Pick this
So
one.
now this one next.
Yep.
And plug that one in there.
Yep. That one's working. Now we have the complicated joints now.
Yeah.
Should we try those out?
Let's try them out.
Okay.
This is going to test the weight.
Yeah. So
how well they can move.
We're going to test, I guess, this one right here.
Just try to keep your finger out of the way so that it doesn't
Sure.
jam up.
Point at it that way. Yes.
Oh my gosh! Whoa!
Uh-huh.
Look at that, guys.
Nice range of motion too. It's moving.
It's alive.
It's moving. Okay. I guess
Fantastic.
We can now test this joint now.
Test the next joint. Test the next joint.
This joint right here.
Yeah. Here we go. Here we go.
Pivot.
Make sure I don't plug it in the wrong direction.
And oh yes, that looks nice. Oh, it goes a little bit too far
On that one side.
on the one side. You notice that.
Oh, so it might need to.
We might need to adjust this
adjust
a little
these
bit.
a
Yeah,
little bit.
that's good that we're doing it now. So I guess we'll test this set here.
That one's going to go too far too.
Yeah. But
So I'm
test
gonna have to
another tip. We'll do
redo
the
that
tip.
one
Yeah,
a little bit.
now we know a little bit more. We'll retest this tip. Hold an angle that way we can see it moving.
Second.
And yes.
There we go.
Yep, there we go. Nice range of motion.
Beautiful.
So we know the tips have a good range of motion.
Okay, so the only ones that need to really be adjusted are the hips, the
Yeah.
ones that are on there.
Yeah, it looks like because of the way we really want not to be 180, but maybe like an angle like that. What do you think?
Yeah. So they never mention any of that in the Thingiverse file. So
It's one of the things you just learn by doing.
yeah. Be wary, there'll be sharks here. So yeah, we're gonna just unscrew them and then resecure them with a different range of motion.
The tip was
Right here.
Yep, there we are. We should actually unplug this.
Oh yes.
Yeah, so
Good call.
yeah, there we go. That way you don't drop them in short of accident.
Okay, so let's remove these hip pieces. And it seems like the range of motion that we want is a little bit different from what is presented. So let me see here. I'm going to pop this out for a moment. So it was here before, like that. And then it looks like...
I think actually what it said, let's think about this.
Should we put it in there and move it and see how far we want it to go?
I think actually, do we want it like at that angle? What do you think? 45
It
degrees.
feels like it should be like that, right?
Yeah, that seems to be the optimal. So that means you want a range to go twist back and forth roughly.
So maybe
that much.
like set it like this then?
Yeah.
Like that?
Okay, let's have you test, move it around and see how far it goes left and right.
I don't have to screw it in. I can
Oh,
just set it in there and
yeah,
then
yeah.
run the test.
Yeah, like that.
And hopefully that'll just do it. Okay. So now if I plug it in...
Okay, let me give you power again. So in a moment, let me do this first.
Okay, very good. So ground
Lift it
first, power next, and lastly the signal.
Yeah, that's better.
That is much better.
Yeah,
That's not why it's not crashing.
yeah, and it gives a nice range as well. Yep. Okay. Yeah. We'll work that out.
Oh, that's beautiful. Okay,
Okay.
so let's do the same thing on the other one. Actually,
Yeah.
let's put that screw back in. Now that we got that fixed out. Oh, that was a pretty easy fix. If only all fixes were so easy. If anybody's in the chat, guys, say hi. We resurrected to the stream after it died. We're extreme necromancers now. Okay, let me double check this one now. You're still plugged in, that one?
Yep. Still plugged in.
Okay.
So let me lift it up. That way it's out of the way.
Right, so we're doing ground net first, then power, and then signal.
Oh, that's right. In the wrong position. Yeah, that's better. That's what we want.
Okay, perfect. So that means that we should probably do the back legs too, right, Alan?
Yeah.
Set the back legs up the same kind of way. Okay, look at that. This is incredible. We're really getting along here now.
I think we should be able to get all the mechanicals done tonight. And then
I think so too.
next week we'll do the software and stuff.
So I'm just going to take this one. That's about the middle of the wiper right there. I'm just going to move it at a slight angle.
Yeah, just 45 degrees.
So from there, like that. About. Should be about right there, right?
Yeah.
I'm not going to screw it on just yet. Let's just put a thing on it, and then we can test it, right? Okay.
I'll hold on to it.
Okay. And signal.
And yeah, it looks about right.
Although it seems like it's
A little bit too close on that side, right?
yeah,
Yeah. We'll stop it.
because it seems like it can go
Yeah.
maybe a little further on this one side.
Yeah.
Come on. So let me pop that out. Is that good now? It seems like it's about 45-degree angle.
Yeah.
Well, so just double check. One more time. I think we're actually going to get all the mechanicals done. This is incredible. Okay, so now let's test it.
Okay, I'll hold on to it.
Thank you. So ground, then power, and then
Signal.
signal. That looks like it's good, right,
Yeah.
Alan?
Yeah, looks good.
Perfect. Okay, so let's just screw that one in. If we have to adjust it, we'd have to adjust it, but at least it's closer to where it needs to be. Oh, actually, I'm not going to screw it in.
Oh, yeah, because
we have to wait for the rest of the pieces.
Yeah, put those other pieces in.
So,
I guess we can just test the servo as is. We don't need to.
Yeah.
We don't need to put
I'll just put the screws. Can I put them in here?
Yeah.
Now. And I think I should remove that for now.
Yeah.
It needs to come back. It's going to come back on in a moment. Leave those at like the 45-degree angles, right? That. And then this one's going to be. Okay, so like that's going to be halfway. And what we want to do is just like take it off and move it for 45-degree angle. I guess we should test it with a shoulder on it. The shoulder actually is really useful for testing. Okay, we'll hold it for then.
Sure. Place.
Okay. And here we go.
It's a little close on that side. What do you think?
Yeah, I think it is.
Yeah. Yeah, it touches it, so that means it's going to jam. So we just have to shift it maybe about 10, 15 degrees.
Yeah. Okay, let's see if that does it. 2, and 3.
Yeah. It's enough clearance now.
Okay, sweet.
There
Sweet.
we go.
Okay, fantastic. Okay,
All right.
so let's let me go back to the other thing. There you go, guys.
Yeah,
So we've got about an hour before it's able to complete. So let's just chill. We're just gonna chill for the next hour, guys.
We got
Wait for the
this
printer to be
nicely
done.
assembled mostly. It's quite nice.
Yeah, actually, the way it turned out worked out really good.
Yeah.
Well, I guess what we should do now is also try and figure out how to get the it to communicate to the other piece, right? The
protocol, I guess, for this
protocol, this thing, the servo controller. So this is our servo controller board. We're going to be trying to get this to interface with the other one. So
there we go.
Interface the two halves together. So the way that I did that before is actually based off of that picture I had there. So maybe I should just use that picture that I have, Alan. What do you think? Should I? You know what? I'm wondering if I should just blindly reconnect it the way it was connected before, or if I just should actually take a look at the
circuit diagram. And do it properly, I guess.
Yeah, that's probably the way to do it.
Okay. Yeah, we should create an actual circuit diagram as well to put in our project folder. That way we don't have to kind of recreate it every single time.
Yeah. So give me a second. I had some stuff that I had done for the quadruped. Quadrupeds here, and I also had the files set out in a different thing. It's just that after after everything got deleted, after I reorganized everything, it all got moved. So give me a second. I have to go take a look through it. 3D design, maybe electronics, maybe. Here's a quadruped planning document. Here we go.
Okay, let's pull that into our project folder in the documents.
Okay. Pull that in here. Boom. Cylinder circuit security schematics. Rigger Launchpad project. A lot of the stuff got put in here. It all ended up in a different project. Maybe I'll find it. My diagrams, quadruped servos.
Ah, there it is. Yeah, let's pull that into our main project.
There we go. And then I think there's more in here. Drones, MOSFETs, diagrams. None of this looks like what we need. Component library? Nope. That's just literally what that is. Batteries? Nope. Darn it, I think I lost all my Arduino stuff. That's what it looks like.
Was that stored in the cloud, perhaps?
Maybe, maybe not.
In our Arduino folder, is anything inside that?
I just looked in there, it wasn't everything.
Well, we could probably create things from scratch anyways.
So let's just go into here. We're going to go to, what was it? TLC 5940 tutorial. Just find a tutorial.
There we are. So let's copy the source code on this and the wiring diagram for this into your project. So
okay, do we have a wiring diagram?
So let's right click and copy that.
This one?
Yeah.
The thing is, like, I don't know if I'm actually even using this one. I think that I'm using it slightly different. Oh no, there's still those there's still a bunch of those resistors and everything else all set up properly. Oh, and hey, look at that! I'm even using the same color wire as them.
Yeah.
I think I did that on purpose.
Yeah. Let's copy this whole diagram into your project folder. So right click, save image as.
WebP?
That's fine. Yeah.
Okay. Should we bring that in here so we can show everyone? Let's add another image source. And this is my keyboard blew up.
There's something wrong with the keyboard.
Yes, keyboard blew up. Yeah, keyboard blew up. I don't think I can do it anymore.
All right.
Hey guys, I think my keyboard blew up. I don't know.
That's been causing. Looks like that's been causing issues.
That's probably been the thing that's been causing all the issues.
Okay, so
not really sure how I'm going to be able to continue the stream.
Well, can I just share this? Can we?
Share what?
And share this whole web browser?
We can. Give me a second. I'm just because my keyboard's going crazy. It keeps closing stuff. So maybe just unplug it for now, and I'll just try and run the stream without a keyboard.
You can use the built-in, I guess, online keyboard and stuff, or yeah, it's
Do you have another keyboard to use?
Do you have one? Cares?
Only Care's keyboard. Care needs her keyboard. I gotta think for a second. What am I gonna do?
Any keyboard downstairs? Oh, there's a computer downstairs.
Oh yeah, there's another computer downstairs.
I'll grab that keyboard.
Although I think like Care took the keyboard already. I think that's the keyboard that she's using right now.
Okay. You need another keyboard at some point.
I think we used up all our keyboards.
I guess you need to order another one. I guess.
Yeah. Oh well, we're gonna do our best, guys.
Yeah. How's the printer going?
It's frozen here, but unfortunately.
Oh, that's good.
Yeah, can you unplug my keyboard?
All right,
please.
Let's see. What's this cable?
That's the one.
Yeah. Try putting it back in.
The parts are about 80% done currently.
Yeah, plug the keyboard back in. Is it flaky again?
No, it's okay.
All right. Fix that.
I spammed up chat, guys. Straight up spammed the chat. Seems like as soon as I close this, it blows up. So.
Yeah, it freezes because it needs. It's because Chrome it's trying to save power by not displaying video that's not actually being viewed.
I see. Okay.
I mean, the thing is, you don't have to go full screen. You just unmax it.
Ah, yes. Although that just messed up everything.
Okay. Yeah, resize it manually to roughly full screen, so that should make it fit it. But we'd usually unmax the other one.
I guess I'll just leave that one open, and what I can do is I can. Dang it! This is so annoying.
Unmax this one.
Hurry!
This is max. Unmax it.
Unmax this one.
Yeah. There. The reason why it's glitching is because you maxed it, so you don't want to max all your windows. Yeah. That keeps the other one working.
Okay, there we go. So now we've got this guy here. And we've got it's all yeah, I plugged it all in according to the diagram that's on this website. So I must have followed this website. Because even the wire colors are the same.
So we just have to copy code as well too into your Arduino project and save that.
Yeah. Let me see if this is plugged into the correct pin. I'll open up this one again. Pin 15 is digital pin 9. I think that S clock is supposed to go into D13. which is digital pin 13 actually, which is all the way over there, the bottom right. So S clock here, digital pin 13.
I think we should upload the code for that first.
Yeah, probably.
Yeah, right, because the current code is going to try to do a servo.
Oh, right.
move.
It's going to try and do some servo move
Yeah.
on it. It's going to blow it up.
Yeah, so we don't want that to happen. So we actually want to upload the code first.
We'll just grab this.
Yeah.
It's for controlling 16 LEDs, though.
Let's go down to 16 servos. System word code below.
Wait a second. Yeah, we don't want to do this.
Mm-hmm.
I feel like I have my own code for it.
Okay, go back to the Google search. Google search on TLC
5940 tutorial servo.
servos. Yes. There.
This one?
That one.
Oh, they're using this thing,
Mm-hmm.
the Spark Fun thing.
Well, as long as it's also TLC, it should be fine because they're communicating with it the same kind of way.
So is that enough? Just take
Yeah.
this.
Mm-hmm.
We use this.
Yeah.
Okay, so let's make a new one. We're gonna call this one
TLC servo or TLC test, perhaps.
We'll actually put it inside the quadruped.
Yeah.
Okay, so now I'm gonna change the Arduino here
Mm-hmm.
to the correct one. Open that up for you guys so y'all can see it. I'm just gonna hijack that a little bit. Apologies for everyone. Like that. Okay, so now from here we're just gonna boom, shove that in there. How many servos on the chain? We're just gonna do one, right?
Yeah, one for now.
TLC initial servos. Loop for I equals 0. I equals 0, I equals 0. Oh, so for int I equals 0. So it sets I as equal to 0 initially, and as an integer. Then it says I is equal to 0. And then angle negative equal to 10. TLC.set servo I angle, TLC.update delay. Then delay again. Why is the second delay? Where's the second delay?
Okay,
Here?
because the way it works is that
Okay.
yeah, it's a 200 millisecond gap between one pulse and another.
Okay.
So you can't update too often, otherwise it just jitters your servo.
Okay, so is that enough?
I guess so. Save, compile it. Let me give me a second and plug it back in.
Okay.
Nothing else. Oh, we have to install the library.
Just fell down. TLC 4950.h, no
Yep.
file has directory, so
Yes.
we got to go into like manage libraries, right, and
Mhm,
add
yep.
TLC 5940.
Right? Yeah.
Again, they can't really see that because they can only see the main screen.
Yeah. Well, you can force it, but
We're just going into the library manager and we're looking for the drivers we need. Sparks on Fun 5940, which
oh,
one?
there he is.
We should find out which version they use, right?
Okay. So this guy, he has what library do you use? He used actually his own library. If you go down, he mentioned that he has a GitHub with its own library.
I feel like we should just be using this one though, or the one that we were
Yeah.
I saw from the
It'll
original
still be
one.
fine, I believe.
If we go to TLC 5940 tutorial, this one here uses the default one, I think.
So all we do is just it should work similarly because it's just the code is just to talk to.
Okay, we need that TLC 5940 Arduino library made by Alex Leone.
Mm-hmm.
So neither of these were made by Alex Leone.
It should still be fine because it's fundamentally it's using the SPI.
So which one should we use?
Uh,
Maybe this one. This one's got versions.
yeah,
That's all.
I think it's most like the SparkFun library.
Okay, let's use the SparkFun library.
Yeah. Mm-hmm. And they mentioned they have an LED breakout or the SparkFun shield. Actually, I'll go to the PWM shield, SparkFun shield, because that should give us a circuit diagram. And then we can double check to make sure. Go to documents. And yeah, go to the schematic because that's double check if the schematic is dissimilar to what the other guy's is. Probably is.
I don't know how to tell.
Okay, so we have to kind of look at the right over there. We should be able to see which pins go in from the S clock pins.
I almost want to take a picture of this and show everyone what I'm looking at because I'm like no idea.
Yeah, let's save that. So we have to maybe do some coding before our next stream.
That's okay.
Do this already. Yeah. So yeah, that's a SparkFun. You might want to rename it to SparkFun Shield.
But before I didn't need to do any of this stuff.
Yeah. But the key, this is key. What we want to know where.
Do we want to use the SparkFun thing, or do we want to use this TLC by Paul Stoff?
The thing is that we don't know how they configured it because it depends how they configured SPI.
Okay,
yeah.
So this one seems like it's using their special LED breakout drivers.
Yeah, but all is we just have to know what schematic, what pin to use with Arduino that goes into what pin on the TLC.
Okay, so how do we know if this is the correct one?
We don't until we see what the circuit diagram is, because it fundamentally depends on how they program the output pins.
So we gotta do this thing?
I would save it and then we compare it. Does it match the circuit diagram that you have here? If it does, we're safe. Otherwise, we just rename the pins or reconfigure the pins.
Shield / TLC 5940.
So just look at the MOSI and S clock pins. Which pins do they go into? So,
is that on this guy?
Look. So the TLC. I'm looking at that diagram. I'm seeing. Okay, it looks like the S clock goes to pin 1. S in pin 2, S out pin 23, and if those are the same, that's all that really needs to be done. So I don't know if it is. So we should we should really have a circuit diagram for this as well too.
So let me hold up.
Yeah.
It seems like pin 1 is not S clock.
Okay, so.
Yeah, pin 1 is definitely not S clock.
Okay.
They have some sort of modified chip.
Well,
or their shield's different because this is a 5940 RHB, and this thing is just 5940 NT.
Okay. And okay, so right.
Yeah, it seems like a different chip.
Different chip. Okay. So in this case,
we can't use that one.
In this case, in order to know where the library works, we need to know how it.
Can we just take this one by Alex Leone and use the same one?
Okay, yeah, but which library is he using?
How do we get it?
Let's look at the source code. So he looks at it. Okay, it looks like.
Oh, here we go.
Yeah,
Arduino library by Alex Leone.
Okay, Google Archive. All right, so.
Well, this is a really broken website. This is an old website.
Yeah, this guy hasn't supported for a long time.
Yeah, let's not use his. Hey, can we use like maybe this other one then maybe?
Well, again, we need to know how they configure the pins. So let's just go to that library, go back to documentation on that library, go to
Should we use the ones that are in here, like just the public ones?
Yeah. Let's go to the other one.
Let's say 5940.
Yeah.
This one, the Paul Stoffgren one,
yeah,
right?
So let's look at his more info because we need to know how he kind of configured his pins. Right, let's look at this here. So he has a data sheet. Let's see how. Let's go down. Let's see how he actually configured his hardware stuff. Oh, circuit diagram. Oh, he does. Oh, a Leone.
One.
Yeah. Save that, and then we'll check. Is that the same as yours? Or not?
Let me double check.
Yeah.
Oh shoot! Shoot! The programmer fall down.
Oh. Unplug it for now.
Yeah. Thank you. Let me just double check. Can I see the? Where's the? Oh, here it is. Here it is. Okay.
So I guess we look at how the MOSI and S clock pins are configured.
Give me a second, Alan.
Sure.
We're down to 2 viewers now.
Yeah.
Let me double check here. We might have to end the stream for now.
Yeah, we have 12 minutes before 2:30 anyway, so
Yeah,
Yeah.
I'm down to 2 viewers. I guess we're gonna end it there, guys, and we're gonna try a little more next week.
Yeah.
I'm gonna be playing around with this. I'm gonna do the boring stuff of getting all of the
circuit diagrams worked out,
yeah,
and,
circuit
and
diagram
the libraries
worked
configured
out.
properly.
And we'll have everything in here. But look at this. We actually got like a good chunk of this done, guys. That's pretty
about 80%
impressive.
assembled, yeah.
You know what? Before we stop, let's take a look at the
3D printer.
The 3D print here,
Maybe. Okay, it's nearly there.
and maybe here, I can maybe uninstall this one. How can I uninstall this?
Yeah,
Smart
I
Club?
saw that one, yeah.
It seems the other one was. How do you uninstall it though?
I guess we can't.
Okay.
Or I guess we'll worry about that later.
Okay. Yeah, it says it's got about half an hour left. I'm just gonna end there though. I think, guys, we did pretty good tonight, and I hope that you guys enjoyed that. And if you guys did, please give me a follow and check me out on YouTube.